Okay, so we're going to go ahead and run through these notes pretty quickly. It's a pretty simple concept. We're going to start off with a few pieces of vocabulary, and then we'll kind of finish up with some problems that should look pretty familiar to you. So this entire unit is all about polynomials. A polynomial, it says up at the top, is a monomial or a sum of monomials. So monomial is a new word to you. It's just another word for any term that you're looking. So when we talk about combining like terms, those terms that we're talking about are the individual pieces that are broken up by plus or minus signs. So if we are looking at this binomial, so binomial, you know bi means two, so that would be two terms. So this 5x is one term, this positive 2 is another term. With a trinomial, obviously tri is now 3, so x squared is a term, 5x is a term, and 2 is a term. It's broken up by these plus or minus signs. So a couple other pieces of information, not that you necessarily need to necessarily memorize them, but we will look at, generally when we are looking at these polynomials, we look at them in standard form. Okay, so standard form means the term with the highest exponent comes first. So we can see that the x to the third is the highest exponent, so it comes first, then the x squared, then the regular x, then the number without a variable on it. That's generally how we see them if we are looking for standard form. It is good practice moving forward to always write your final answer this way. So we're going to write our final answer with the highest exponent term first, and then work down from there. That highest exponent is also how you name it based on the degree. So again, not necessarily pieces of information that we need to memorize, but good things to realize as we're moving forward and talking about these things. Okay, so just a quick recap on combining like terms. Remember that we always want to, when we are combining like terms, we always want to make sure that we are looking for two things when we are combining. We're looking for same variable and the same exponent. Okay, so here 2 apples and 4 apples is obviously going to make 6 apples. 3 oranges and 1 orange is going to make 4 oranges. When we're looking down at the problem, I want to make sure that I'm taking x's with x's. So I scan through and I don't see any more x's, so that stays there. With the y's, I see a 4y and no other y's, so I'm just going to bring the plus 4y down. Then I see the z's, so a plus 2z and a plus 4z is going to be a plus 6z. And then lastly, plus 11 and plus 2 makes plus 13. I've combined like terms. I do actually want to show you one more. So say we have something like 2x squared plus 3x plus 4x minus 2x squared. Okay, so we already looked at in the previous problem same variables. We also want to make sure that when we're combining like terms, we're looking for same exponents. So you have to remember a couple things here. When we are looking at exponents, we always want to make sure that we are not mixing x's and x squareds because those do not have similar exponents. So when I'm looking at this problem, I see the x squared term here. I want to make sure and come over and match it with the other x squared term. We also, since doing the multiplication and stuff with our exponent rules, sometimes now have a tendency to change exponents. Remember, when we are adding and subtracting, we are not changing exponents at all. So I always talk about splitting your brain in half. You got to make sure you keep half of your brain for those exponent rules where you are changing the exponents, and keep the other half of your brain for adding and subtracting where you have to have like terms and you do not change the exponents at all. So when I'm doing this problem here, I have 2x squared minus 2x squared. So 2x squared minus 2x squared are actually going to cancel each other out, and that's gone. And then I have 3x plus 4x, which is positive 7x. Remember, x and x don't make x squared because we're adding, we're not multiplying here. So that would be my final answer. Okay, let's go ahead to the next page. Alright, so at this point you are going to go ahead and do the first 4, so 13 through 16. You can pause the video and go ahead and do those 4, and then you can play the video when you're ready for me to go over them. Okay, so on 13, I have negative 4x plus 6x. That's going to be a positive 2x. And then I have a positive 9 and a negative 14. So 9 minus 14 is negative 5. On number 14, I have negative 3a plus 7a. That's going to make 4a. I have negative 2 plus 5, which is going to make a positive 3. Excuse me. Then when we get to 15, we got to make sure and be careful with x squareds and x's. So I'm taking this x squared with the other x squared. So 1x squared minus 1x squared is going to cancel. Then I can use 3x and 6x makes 9x. And then I have plus 5 and minus 4. So 5 minus 4 is positive 1. So plus 1. That's my final answer there. And then on 16, I have a single t squared and 2 more. That makes 3t squareds, right? Not t to the 4th, so be careful with that. Then we have 3t to the 3rd minus 2t to the 3rd, so that's a positive 1t to the 3rd. Remember, the 1 is optional. And then we have negative 3. Oh, yep, see, I almost did it, see? So here in this first term, it's a negative 3 without a t. Here in the second set of parentheses, it has a t, so I don't want to combine these two together, okay? So we'll just bring that negative 3 down, and I'll bring that plus 7t down. And again, as I said on the first page, we want to get into practice of putting it in standard form with the highest exponent first. So I'm going to bring that t to the 3rd term first, then my t to the 2nd, so 3t squared, then my regular t, so plus 7t, and then lastly my minus 3. And now that's in my final answer of standard form, okay? So good practice to start putting them from highest to lowest. Okay, so let's look at 17. So as we are kind of, and normally, you guys know I would probably have you discuss these in your groups, but since it's e-learning, I'm just going to kind of talk through this. So we want to look at the differences between these problems down here with these problems up here. Hopefully you're recognizing that this says find the difference, and there's a minus sign in the middle. So there is one and only one way that we are going to deal with this, and that is simply distributing this negative in front of the parentheses. Remember, it's like a negative 1 into the parentheses. So this g minus 4 up front is going to hang tight and stay put. Negative 1 times 3g is minus 3g, and negative 1 times negative 6 is plus 6. After and only after we distribute that negative 1 in, now I can go ahead and go back through and combine like terms. So a single g minus 3 more g's is negative 2g, and then negative 4 and positive 6 is plus 2. And there's my final answer. So go ahead and pause the video and do the other 3, and then you can unpause the video when you are ready for my answers. Okay, on 18, distribute this in. So the negative 5h minus 2 stays. Then I get negative 7h minus 6. Now I can combine like terms. So negative 5h minus 7 more h is negative 12h. And then negative 2 and negative 6 makes minus 8. So there's that. Number 19, distribute this in. So since there are 3 terms inside the parentheses, I just have to multiply it 3 times. So I have my negative x squared minus 5. This stays put. Now a negative times a negative is a positive plus 3x squared plus 6, x, not 6, and plus 8. So I distribute that negative in and it cancels all those negatives out. Now I'm ready to combine like terms. Remember, I want to put my highest exponent first. So my x squareds go first. Negative 1 plus 3 is 2x squareds. Then my regular x term next. So plus x. And then I can deal with my numbers. Negative 5 and positive 8 makes plus 3. So if you kind of see there up above when I did problem 16, I kind of just brought it straight down and then reordered it. You are welcome to still do that, or if you want to kind of do it how I did down here on number 19 and just kind of look it over first, say, okay, I'm going to bring my x squareds down, then my x's, then my numbers to get them in the right order. You can certainly do that as well. All right, and then last but not least, number 20, distribute that negative into the parentheses. So my first set of parentheses is going to stay the same. And then distribute that in. So I'm going to get negative 5k to the 3rd. Oops, I did a boo-boo, didn't I? Let's get rid of this x. Accidentally put an x in there instead of a k. Okay, so negative 5k to the third minus 7k, and then that's going to be plus 3k squared. All right, so I want my k to the thirds out front because that's my highest exponent. So 6 of them minus 5 of them is going to leave me with a single k to the third. And again, that's optional if you want to put the 1 or not. Then my k squareds. So I have a k squared here plus 3 more k squareds here. So that's plus 4k squared. And then I have a regular k term. So minus 7k. And then my negative 4, so minus 4. And I got everything, so that is my final answer there. So pretty straightforward stuff. The only real thing, or the only couple things that you really have to look out for is remember, when you're adding and subtracting, do not change the variables. Don't change the exponents like you would when you're multiplying. And then secondly, if you see that minus sign in the middle of the parentheses, make sure you distribute that in first so that you are adding or subtracting accurately.